Pleasure to be here. So a little bit about us, How24K. I'm not sure you've ever heard of us before. We're a British-Dutch organization, probably more Dutch than British, you can tell because we have an orange logo. But we're small and we cover many different sectors. So I represent the water sector, the water part of How24K. But we look at the application of data science and artificial intelligence across the built environment. So today I want to get across two things really. The first being that AI can help across all parts of the water sector. And the second is that AI is not as difficult or not as complicated or not as inaccessible as it ever used to be. It's in fact much easier to get hold of and implement into the things that you're doing today. So what we do as our organization, which is young and small, we create AI solutions for the water sector. And we're not limited in who we work with, so we're very active with water utilities, but we're also working with major water users, with technology providers, infrastructure providers, consultants and contractors. The place for AI can sit in amongst any part of those new and traditional companies. So we would say if you've been thinking about an AI solution or data science in the things that you're working on, then please let us know. We've built about 40 bespoke AI solutions today across asset-centric industries. And as I was waiting there, I was thinking, I know that we've actually we've built a solution that is operating some part of the road network the road network in the Netherlands. I think it's controlling the toll. But I thought I probably wouldn't mention that just in case you've had a bad journey here. But we're across. So, right, big question here. I think you should always consider AI in your work, right? And why is that? And that's because the best possible decision is the one that's made with a full view. Okay, so the analogy that I've got on the screen there is sport. And whilst sometimes decisions in sport are controversial, even the introduction of technology in sport has been controversial, I personally believe it's brought an undeniable shift and improvement in the way that sport is delivered. And as we know, decisions in sport are much more important than anything else in the world. Life and death, it can seem. Actually, decisions in environmental management are far more important. I think we know that, but we forget that. We forget that every day, as those in the water sector, if you're at the front end, delivering services or operating or managing, you are making management operational decisions every day, maybe thousands of decisions every day. And those decisions can be improved. Your decision-making process can be improved with a better view of what is happening. And really that's what AI can bring. Just again, think about the value of being able to always make the best decision. So, those values can be, my view, across the water cycle, but if we look at the way that services are delivered, certainly there's a massive way of improving service to the end user, the recipient of water services. Many of the technologies that I'm going to talk about in a minute, they're about increasing efficiency. There's a universal drive to spend less. Many solutions around optimizing processes, and I think the theme of today, or many of today's themes, cover process and maybe some of the minutiae of process, all the way through to the sort of the bigger process. Optimizing processes is really very, very core for the use of AI. Extending asset life, again, that links back to cost, but can we get more from assets by looking at their performance differently, looking at how they're delivering their service better. And then, of course, I think the wraparound is the potential, if you can look at what you have differently, i.e. your data, the data that you've got that's telling you how all these things tie together, there are the opportunities to reduce cost, reduce energy, and your chemical and greenhouse gas footprint. So I think it's invaluable to consider at every step. So I know some of the companies that we speak to tell us that, look, there's so much AI around. It's, you know, everyone claims to have AI in their solutions. Surely it's already been done. No one's actually said surely it's already been done, but you get this impression that there's so much AI going on that it's been and done. So we did a gap analysis, and I'm just going to run through that gap analysis really quickly. And it's about the municipal water cycle. So treating water, distributing water, collecting sewage, treating sewage, and bringing those things back to land. Of course, that cycle is tightly connected with catchment management. You know, you can't talk about abstracting water and treating it without understanding the effect it can have on a catchment, on river management, on waste management, and actually the food chain and food management. I'm not going to go through those today because it's such a big, ends up being such a big subject. But, you know, just recognizing that this cycle in itself is tightly combined and aligned with other cycles is really important when we look at the impact of decisions and decision making. So this is water treatment. This is what we looked at with a gap analysis. And I'm going to run through these really quickly because I don't want to spend too long. But what you're looking for there are, with the activities around the wheel, which ones have got a white or an orange circle. And that indicates that there aren't any solutions. There are no known solutions that are out there that involve AI. And of course, this is a changing situation. There are new AI solutions coming out every day. So this is about 2 or 3 months old, I think, this analysis. So there's no guarantees, and actually I make no guarantee of covering everybody. So if there's someone in the audience who goes, well, where's my solution on there? Apologies for that. These are indications of the areas where there has been some good development of AI solutions. I'm going to pick out one or two just to talk it through. CreaTech 360 make an amazing, it's a bit of a black box actually, but a way of controlling aeration such that you can optimize the aeration process in either a drinking water or wastewater plant to reduce energy use using machine learning. Fantastic, using existing data, very low capital investment. And then Synauta, I think I've said that correctly. We've been hearing and seeing lots about membranes today. They have a solution that optimizes and extends the asset life of desalination membranes by looking at the performance in detail over the life of membranes and actually advising on different timings for when backwash should occur. I'm going to whiz through the rest. Actually, with water distribution, where you've got pipework that's underground and hidden, actually there are more problems and therefore maybe there are more solutions today. Plenty of solutions around looking at pipe condition and understanding when is a good time to replace a pipe. So there are a number of companies that produce an off-the-shelf product that you can buy today that's going to help to understand, and behind it is really good AI, so you've got Voda AI and Ecologics there. I won't go through the rest, but actually picking out water pumping. Actually, when you're distributing water, the cost, 80% of the cost is maybe less so here in the Netherlands where it's so flat, but in hillier regions or the cost of moving water from one place to the next once it's been treated constitutes 80% of the energy that's used in that whole process. So there are a few really good solutions there around choosing the right time at the right time of day to make sure that you have water in the right place where you need it. AI is absolutely, and data science is underpinning those solutions. Sewage collection, yeah, we've seen an explosion in the volume and number of new solutions around looking at the sewage network differently, the sewage collection network differently. Interesting to see that this has become, or has been becoming, a much greater area of focus around the world. You have long-standing companies actually that look at sewer inspections and use computer vision AI to understand where sewer inspections reveal certain blockages or certain types of issue within the sewer. It's interesting that those are solutions, A, that there's many of them, but B, they're about making life easier for the end user. They're not necessarily revealing anything new that a person couldn't do themselves. So a range of things around the sewage network. Look how few there are on sewage treatment. We've got our own logo in there because we're looking at the activated sludge process, but not so much going on around that. Some very good solutions that cover the whole of the sewage treatment process with a sort of light touch around AI. And then again, the same with sludge treatment. I wouldn't like to assume that because there aren't solutions here, there isn't a place for them. I'm having conversations with organizations all the time that are opening up the idea that if you look, you will see a real strong need for an application for AI and data science. And that's what I want to urge you today, to really think about, okay, could you apply data science to the work that you're doing and result in an improvement in the way that things are managed? So I think with the fact that there are gaps in that cycle, and I think there will be for a very long time, just a bit about what we do and how we do it. So we look for, with a consulting role, we look for previously unseen connections within data, and I think that's probably the most exciting application of AI, is to look at data in a different way, look at what we can see and reveal secrets that have existed in that data for years. And this picture on the bottom left there is a multivariate view of an application, I think, to look at asset management. We are, as humans, are only able to consider a few dimensions at a time. Computers can do much better than that. And this is why I think it's really important to consider AI or data science as a way to reveal new patterns that we can't see as humans ourselves. The other thing that we do is we create end solutions. We create those for our customers, and those end solutions are truly about using that information, using the outcomes that come from applying the data science. And they tend to be dashboards and very functional applications. So I've got a few examples of some simple, straightforward applications of AI that maybe help to bring that to life, the kind of things I'm talking about. A bit of a grainy picture, that, I'm afraid. But the example here is, can you use a camera as a sensor? So we were approached by a water company who said, believe it or not, we have cameras on our combined sewer overflows. So I think someone said this morning about the canals in Amsterdam not having sewage in them that often. It still means that there is a situation where there is sewage in it, and that comes from the kind of outlets that are on the screen there. Now, what this water company is now doing is they've put fixed cameras looking at these outflows to see whether they're flowing. And what they wanted us to do was tell them whether or not that grate that was actually getting blocked with pieces of wood or plastic bags or the usual detritus that maybe comes from a sewer or a rainwater drain. Yes, we can. So we take that data, the camera data, and we apply computer vision AI, and we can point out that it's blocked for them. However, we can also say what's blocking it. So is it rags? Is it pieces of wood? Is it plastic bags? We think we can also tell them what the water level is if they put a gauging stick there. Not particularly complex, but the camera can see it, we can interpret it. From that, we can also tell the flow velocity by looking at the speed at which the surface of the water is moving. And we can also tell whether it's clear or cloudy. So before you know it, you have a solution from a camera, a standard ordinary camera, that is now using that as a sensor. The clever bit is the application of the AI to unlock the potential that exists in maybe just a simple camera. They're simple, I say they're simple, they're not simple. But the answer, the thing to remember is this was not a 2-year project. This was 12 weeks to create and implement such a solution. The next one, another example of something a bit more complex, is around, it took a little bit longer to make, but this water company wanted to understand, the person responsible for water treatment wanted to be able to get up in the morning and say, what's the risk at the 15 water treatment sites that I'm responsible for? What's the risk that they're going to fail today? So that needs a dynamic view, okay? They have, like many water companies, water utilities, they have lots of sensors telling them about water quality, incoming water quality, about chemical stocks, about the weather, a whole range of different pieces of information coming at them. How can I tell whether there's a problem that's brewing? Can we combine all this information and turn it into something that I can use? So this is a platform that we created, that looks at all of the influences that could make a treatment site fail. So you'd think, okay, there'll be some pumps there. Yeah, there are some pumps. But like most water utilities, you don't just have one pump. You maybe have 3 pumps, 1 that you use, 2 that are on standby, or maybe 4 pumps, 2 that you use, 2 that are on standby. So if 1 pump fails, it's not a problem. But if 2 pumps fails, it is a different problem, and it changes the risk situation. So what's on screen there is a representation of the view that screenshot of the view that the user will see, with anything red being bad. You know, that's a nice standard way of highlighting issues. So actually there's a story behind this which I won't go into, but this is river water, treating river water. The quality of the river water went down. More chemical was required to treat the river water. They were running low on chemical stocks, panic stations, because we're going to run out of the ability to treat the water. So this was about creating that risk. Now this is complex multivariate risk analysis that I was talking about before. It's actually too difficult to try and sit down and go, okay, if that pump fails, if we run out of chemicals, but maybe the weather's not going to change. You know, to be able to be, that was only 2 variables, 3 variables. You know, when you look at many variables, it ends up being more complex and difficult as a human to do. So this is where we employ a deep neural network, AI, and this is much more on the left-hand side of the future vision part that I was explaining before. And final example from me, this one, again, I think a really straightforward application of AI, and I'd like maybe to leave you thinking, okay, yeah, maybe this could be interesting for us. This was if you can read the text, good luck, but it says things, it's text that comes from the field. It's proper English, but it's in operator speak, so it's abbreviated, it uses acronyms, it says what they did. And unfortunately, this particular company had captured all of that data in the text field of their work management system. It's very common. It's very common. Now, you can't, as a human, I can sit down and I can read that and I can say, okay, he went there on that day and he fixed something, and I can work out what he's done, and I can do that. but there were 18,000 site records. It would be a very laborious task. So I don't say that this is a groundbreaking change in the way that the water sector's moved to. I'm saying that this is a real simple application that's saved a lot of time and actually wouldn't be done. They just wouldn't have done it. But what was happening is they were going back and backward, returning to the same sites, and they didn't know why. They couldn't look at it. And what we've done is use what's called natural language processing. This is taking that free text data. It could be speech, but in this case it was written text, and allow the system, the AI, to read that text and learn. It can learn, it can consume, 18,000 records was quite small. It can consume millions of records and see the patterns that come from it, and turn those patterns, that text into data. And then once you have it as data, you can start to say, okay, this site is a problem, this one needs to be fixed. These people seem to be part of that problem as well. Maybe they need to be educated in how to fix this situation. Again, really, this was quite a straightforward, quick project, a 6-week project. So to give it some context, I don't believe that AI has to be big, world-changing changes. Often it can be small things that can move things forward in a small way. Right, so there are limitations, being very clear, and I think this is the key one here. Artificial intelligence is very much artificial. It does not know why, it only knows how. So that means if we find out something's happening, we don't know why it's happening. We just know it is happening. And actually we need to then move into a more scientific understanding of some of these relationships that maybe we can unpick. Machines only know what they've been taught, so you need to have data. You need to have data. If you want to find and predict that something may go wrong, it needs to have gone wrong before. You need to be able to show that there's been a problem before, so the machine can recognize the patterns that can be replicated. And I don't think machines will ever replace humans. So certainly the opportunities outweigh the limitations. Understanding complex relationships between the things that we're working on every day, I certainly think there's a big part to play, and we certainly have not got to the bottom of the potential for AI. AI is accessible. I'd like to hope you can come away with that thought. We're talking about weeks and months rather than months and years for creating some solutions. And yeah, we certainly haven't found the bottom of the potential for AI, and I really think we're in a place where we need solutions to help us solve the biggest and most serious challenges of our day. Okay, thanks very much.
Thanks, Matthew, for